Let's take a look at the practice quiz for Standard 7. This is the first part of our rationals unit. Number 1 says simplify the following rational expressions, state any restrictions on the variable, and show all of your steps. So for number 1, the very first thing you want to do is factor everything out in the numerator and everything out in the denominator. So I see that I can't take out a greatest common factor from x squared minus 9, and there's two terms, and they are both perfect squares. So I can factor that into a difference of squares, which would be x plus 3 and x minus 3. That's the square roots of each one of those terms. At the bottom, I see that I can't take anything out of all three terms, but it's a trinomial, so I need to set it up and multiply to get negative 3 and add to get 2. What numbers would do both? Multiply to get negative 3 and add up to get 2. So we would need to have 3 times negative 1, because 3 plus negative 1 would give us 2. Then let's write those in. So we have x plus 3, x minus 1. So we get everything factored out first. Then we see what the restrictions are. So you can go ahead and state the restrictions on the variable, because that's where the denominator would equal 0. And they're easy to see before you cancel anything out. So I see that I have x plus 3 in the denominator. So we would say x plus 3. That cannot equal 0. And so if you solve that little equation, you see that x cannot equal negative 3 for that part of the denominator. And then you also have x minus 1 as another factor in the denominator. So x minus 1 cannot equal 0. And if you solve that little equation, you see that you would have a restriction at 1, because that would make x minus 1 equal 0. Now, let's cancel things that match at the top and the bottom in the numerator and the denominator. And then let's bring over what's left. So our simplified form, I'm going to scoot these restrictions over a little bit to write my simplified form, which is just x minus 3 over x minus 1. You can write those parentheses, but you don't have to write them. Either way is fine. And then you have your restrictions. And that would be it for number 1. Let's take a look at number 2. It says to divide the following rational expression, state any restrictions, and show all of our work. So in dividing, we want to keep it, meaning keep this first fraction in the same order that it's written in. We would like to change it, so change dividing to multiplying, and flip it, meaning flip this flip this second fraction over. So let's get started. Let's keep the first one in the same order that it is and go ahead and factor it out. So I can't take a greatest common factor out of y squared minus 4. There's two terms that are there and they're perfect squares, so we can factor that into a difference of two squares. So we could put y plus 2 and y minus 2. In the denominator, we need to factor it as a trinomial and say what multiplies to give us 36 and adds up to negative 12. So negative 6 times negative 6 would be the numbers that work. So we need y minus 6, y minus 6. We're going to change this to multiplying. And then as you factor the second fraction, just remember to flip it over. So I see I've got 5y minus 10 in this numerator. I can take out a greatest common factor of 5, and I have y minus 2 left over. That's a binomial, but it's not a perfect square, and they're not perfect cubes, so we can't do anything more with y minus 2. And notice I wrote that in the denominator now. And in my original denominator, I need to factor out the trinomial. So I need to multiply to get negative 6 and add up to negative 5. So the numbers I need are negative 6 and 1. So let's put y minus 6, y plus 1 in our numerator. Now we have kept it, changed it, flipped it, and factored everything out. So we're in good shape. Let's write out the restrictions. What can y not equal? So you check out the denominator and see what would make this equal to 0. So we say y minus 6. That cannot equal 0. And if we add 6, we'd say y cannot equal 6. The same thing would happen with the y minus 6 beside it, and we don't have to write that twice. Once we've written it, it's good. So look at y minus 2. Think y minus 2. That cannot equal 0. So if I add 2, I would say y cannot equal 2. It's good to do that while you can see your denominator clearly. And then let's cancel out common factors that we have in the numerator and the denominator. So we have y minus 2, 1 in the numerator, 1 in the denominator. We have y minus 6, just 1 in the numerator and 1 in the denominator. They do not all three cancel out. And then let's write what we have left, our simplified form. So in the numerator, I see I have y plus 2 and y plus 1 left over. Just write them as factors, put parentheses around them. And then in the denominator, I have 5 times y minus 6. And you just check and see if you can simplify that any further once you put it back together, but we can't. So that would be it. Let's look at number 3. 3 is subtract the following rational expression. Write your answer in simplest form. So to subtract, we have to get a least common denominator. That's our first goal. So if we look at these denominators, we have x minus 5 and we have 3. So the only way to make those the same is to put 3 times x minus 5 as our denominator, because we can definitely turn them into that least common denominator. So in order to do that, we multiply this first fraction by 3. So we get 21 over 3 times x minus 5. And then on the second fraction, we just have to multiply by x minus 5. And let's just bring down what we have, and then we'll put it all together. So once you have a common denominator, you want to keep it. So put 3 times x minus 5 in the denominator. Then let's focus our efforts to simplify the numerator. So I see 21 minus, let's see, it's going to be minus 4x times x. So that's minus 4x squared. And then it's like a negative 4x times negative 5, which would be positive 20x. And then we certainly just need to see if we can combine anything, or let's just write it in standard form. So we have negative 4x squared plus 20x plus 21. All still over 3 times x minus 5. And then there's nothing we can take out of that numerator, so we can just leave it like that. And then let's write out the restrictions. So we would say x cannot equal, and if you look back at the denominators, when you've made them the same, or if you look even at the original problem, we would just need to say x cannot equal 5, because x minus 5 cannot equal 0 based on that original denominator and when we got a common denominator. So that would be our only restriction we need to make a note of. All right, let's look at number 4. 4 is solving the rational equation, and it's got one fraction equal to another. So you're able to cross multiply this type, and we could say 2 times x plus 3 equals 4 times 7x. And then you just solve it from there. So let's distribute the 2. So we get 2x plus 6 equals 28x. Let's move the one that has a variable and is smaller, like a smaller coefficient. So 6 would equal 26x. And then we just need to divide both sides by 26. And then we can just reduce that a little bit. So 6 and 26. They would both divide by 2. So we would get 3 over 13 equals x. Now let's just state the restrictions. So x cannot equal, same idea, it's whatever would make that denominator equal to 0. So we could say 7x cannot equal 0. If we divide by 7, x just cannot equal 0, because 0 divided by 7 is just 0. Then say x plus 3, that cannot equal 0 either. And if we subtract 3, we see that x cannot equal negative 3. So we just had 2 restrictions. As long as what you get for your solution, right here we got 3 over 13, is not a restricted value, then all is good. If it happens to match, like you get a value that is restricted, you would have to say that you have no solution. It's an extraneous solution. So that's what would happen in that case. And it sometimes does happen. So let's look at number 5. We've got denominators. We're trying to solve the rational equation, but this one has more than one fraction involved on one side, so we cannot just cross multiply. We've got to figure out what the least common denominator would be between all three. So we got 4, 2, and 6. We could turn all of those into 12 with the least amount of work needed. So let's multiply this first one by 3, and we would get 6y over 12. Multiply the second one by 6, so we get 6 over 12. And multiply this third one by 2, so we get 2y over 12. Now, when solving the equations and you get a common denominator, then you can take them away. It's the same thing as if you multiplied everything by 12, they would have all canceled out. So that's why that's okay to do that. All right, so bring down 6y plus 6 equals 2y. And let's solve that. So I'm going to subtract 6y this time just so I don't end up with 0 over there on the right side, because that just makes us uncomfortable when we end up with 0. So we get 6 equals negative 4y, and then divide both sides by negative 4. So we end up with a fraction again, but we can just reduce it and say that's negative 3 over 2 when we divide those by 2. All right, let's look at the denominator. So none of our denominators had a variable in them, so we don't have any restricted values this time. So we just get our answer, negative 3 over 2. All right, so that's it for practice quiz number 7.